Hello students, how are you all? I hope you're doing good. I came with one more topic today, that is Poisson distribution. This is very important for your examination, that too for those who are willing to score out of out. So most of the students may lose some 1 mark questions. So this is a tricky type. Of course it is challenging when compared to any other topic of your statistics syllabus, but I am here to make this topic very easy for you all. So next couple of video, I am sure and I am very confident to make you this topic very easy for you all. So I hope you are ready to learn. So without wasting much time, first I will teach you how to pronunciate, because I see many of the students pronunciation will be done wrong. So first of all, this is Poisson. See, Poisson distribution. So remember students, how to pronunciate Poisson distribution. Of course, it is derived from French mathematician Simon Denis Poisson. This is derived because of some limitation found in binomial distribution. So binomial distribution, I hope you remember there are two parameters of binomial distribution, that is n and p. So Poisson distribution is used when n is very large and p is very small. This is one of the characteristics of Poisson distribution. I'm going to teach you in next slides, of course. So as binomial distribution is having some limitations, hence Poisson distribution came into existence. Okay, because of, I already told you, that is, one is when n is very large and p is small, then only we are going to use Poisson distribution. N is large means when n tends to infinity, and when p is small means when p tends to 0. Okay, you have to remember these 2 points. And np is always a finite number, and it is always denoted as symbol lambda. Okay, so these are the 3 main points you have to remember for Poisson distribution. That is, when Poisson distribution is used when n is larger or tends to infinity, and p is small when it tends to 0, and when np is always equal to finite number and it is denoted as a symbol lambda. Next, let me teach you the definition of Poisson distribution. So this is the definition in front of you. That is, if x is a discrete random variable with PMF, that is probability mass function, P of x is equal to e to the power of minus lambda, lambda raised to x divided by x factorial, where x is equal to 0, 1, 2 up to infinity, because we know x is up to infinity. This is what the difference between this Poisson distribution and binomial distribution, where in binomial distribution x is equal to 0, 1, 2, 3 up to n number, but here it is infinity. And there is a difference of a formula, that is probability mass function. Here it is e to the power of minus lambda, lambda raised to x divided by x factorial, and then x is a Poisson variate and the distribution of x is called Poisson distribution. If you just write this, you may get 2 marks. This is a definition of Poisson distribution, where you need to remember this formula, students. That is, p of x is equal to e to the power of minus lambda, lambda to the power of x divided by x factorial. Next, let me teach you some of the examples. See students, if you remember these examples of Poisson distribution, then it will be very easy to identify where the given problem, whether it is belongs to a Poisson distribution or binomial distribution, right? So now let me give some examples of Poisson distribution. So examples of Poisson distribution, that is the first one, number of deaths occurring in a city in a day. You have to remember this, students. Number of road accidents occurring in a city in a week. Number of vehicles crossing a junction in 1 minute. Number of printing mistakes per page in a textbook, number of complaint received by a company in a month. These are some 5 examples for Poisson distribution. Please remember, this may be one of the question in 1 mark question section, that is section A. So give any 2 examples of Poisson distribution. That means if you remember any 5, but in your textbook there are about 9 examples, you can also remember all those examples, so that it helps you to identify the problem that belongs to Poisson distribution. Okay, if you want to get perfect with all binomial, Poisson and normal, see, all the 3 are very easy, but only thing is practice is needed. In next couple of videos, I am sure you'll be very perfect with all these 3 topics. Now, let me explain some of the features of Poisson distribution. And of course, you can expect some questions out of this. And if you understand this, some of the points of Poisson distribution features, then definitely you can able to solve any kind of questions which you come across. Okay, let me start explaining the features of the Poisson distribution. The first one, see, if you remember probability mass function, that is a formula of Poisson distribution, students, you can write at least 3 characteristics or the features, right? So one by one, let me explain. One of the parameter of Poisson distribution is lambda. Okay, so you know the parameters of binomial distribution, there are 2 parameters, that is n and p, but in Poisson distribution the parameter is only 1, and that is lambda, right? The second point, that is feature for Poisson distribution, is probability mass function, that is p of x is equal to e to the power of minus lambda, lambda raised to x divided by x factorial. You already learned this. This is a formula. And what is the range of x? 0 to infinity. And that is the third feature of Poisson distribution, that is x is equal to 0, 1, 2 up to infinity. That is the third one. See, very simple. The first one parameter, that is lambda. The second, probability mass function, you have to remember and write down that. And the third one is the range of x, that lies from 1 to infinity. 3 features you learnt. Next, the fourth one. In this Poisson distribution, mean, the formula of mean is lambda. And variance is also same. I hope you're understanding. What is the formula of mean? In Poisson distribution, that is lambda. But what happens in binomial distribution? Mean is equal to NP there. But here, mean is equal to lambda, and also variance is equal to lambda. That means you have to remember, see, next feature, mean is always equal to variance, because mean is lambda, variance is also lambda. So here 2 features. Whereas standard deviation, we know that square root of variance, hence as variance is equal to lambda here, so square root of lambda is nothing but standard deviation. So this is 5th one. So 5th one is mean is equal to variance. And the 6th one is lambda is, if it is not an integer. Poisson distribution is unimodal. That is only one modal value. Unimodal means one modal value, that is lambda. If lambda is not an integer, okay, integer, z means integer. If it is not an integer, the PD, that is Poisson distribution, you will be having only one modal value, that is we call it as a unimodal, that is lambda. If lambda is an integer, okay, Poisson distribution will be having bimodal, that is bimodal means 2 modal values. So one is lambda and another one is lambda minus 1. Simple, right? So please do remember. So next, again, I have 3 more features of Poisson distribution. Poisson distribution is positively skewed. That means the right side tail will be larger. Okay, that is we call it as positively skewed. And Poisson distribution is leptocritic. That means it will be having a peakiness, right? Then when lambda is large, Poisson distribution tends to normal distribution. That means when lambda is very large, then we can't use Poisson distribution. We need to use normal distribution. This normal distribution is the next topic for you all. You need to remember this 10 features so that it will be very easy for you all to solve any kind of problems if you come across. So I hope students you understood all the features of Poisson distribution. In next video, I'm going to teach you how to solve the problems. So I'll take up some problems and start solving.